I'm Karen Gavam. I'm CEO of LunarG, and we have developed the Vulkan SDK, which has validation layers and a loader, among many other things. And what I've brought for you here today are the key architects and developers of the loader and validation layers. The table, we're not going to introduce each one individually. You can see them on the slide. But they're the experts. They're down in the code. They know how they work. And so they're going to go through some material pretty quickly. And then at the end, we are going to reserve some time for questions. Just to let you know, and for those of you who pull up your phones and take pictures, the information for this presentation actually is online and now at lunarg.com, so you can find it there. And so if you want to follow on with your device, that's as well, but also you'll be able to find it later. And as you can tell, we are videotaping this, and we will post the video later if you want to listen to it later and get, hear the answers to any of the questions again or whatnot. So with that, we'll get going. So I start this end.
Hi folks, I'm Courtney Geldsnyder. I thought we'd start with the advancing to the slides about the validation loader goals. Yeah, Vulkan goals. Sorry, already making mistakes. Anyway, so Vulkan goals. So when Vulkan was getting started about a year and a half ago or so, the idea of a loader was something that was a bit new. And we wanted to do it for several reasons. One of the most important is that we wanted to be able to have, like validation layers, things that you can plug into the API for testing, for diagnostics, whatever. And then when you're done, for production, they're just gone, right? There's no impact to the system at all with them, without them. This allows you to have, a layer ecosystem with a lot of different things, including, of course, the validation layers. Right now, the intent is, and the interfaces are, for layers to work on all the OSs, so Android, Windows, and Linux. Plug-and-play experience. All right, so who has installed drivers on Linux for multiple cards? A handful. It is a royal pain in the you-know-what. And Windows actually does pretty well. So one of the other main objectives was to make that experience painless for everybody. So, that's what you do with loaders. Oops. And of course, the extensibility is all about the layers, right? How do you change the API to capture it, or to run the validation, or maybe even implement extensions, or do other techniques that make the Vulkan API or the Vulkan environment your application is running in more productive. And let's see. Okay, now Windows and Linux.
I'm John Ashburn, Principal Engineer at LunarG, and so I'll tell you a little bit about the Vulkan loader on the desktop. And I know in this jazzy world of computer graphics, loaders are kind of boring topics, but the Vulkan loader is really essential and the foundational piece for the Vulkan ecosystem in terms of making a seamless experience of running applications, across environments with different drivers and layer libraries. So it's open source. It's developed by LunarG, owned by Kronos. That first page you saw already had the GitHub reference to it, the loader and validation layers. The desktop loader uses JSON manifest files for discovering and detailing the layer and driver libraries that it finds. This is done for security and performance reasons. So in discovering those JSON manifest files, there are some standard search paths that are, and I've listed those for Linux, Windows. Linux is some system directories, Windows is in registry locations. There's also some environment variable overrides that you can use if you want the loader to look in some other spots. One thing about the desktop loader is implicit layers. So normally an application enables layers explicitly. So conversely, implicit layers are enabled automatically by the loader when it discovers them. And so then an application can disable these implicit layers if it wants to, and also these implicit layers can be limited to a certain runtime environment on a platform, so they don't always get enabled. There's some other useful environment variables. So if you're a user and maybe want to enable some layers that the application didn't enable, you can set this VK instance layers. These will be an additional, this will be in addition to any layers already enabled by the application. And if you're having problems with your with the loader finding your layers or your drivers on the systems, it's not enumerating these things, then I'd suggest turning on this VK loader debug environment variables, and it'll print out a bunch of log messages to the console. And that's all.
Okay, so the Android environment is a little bit different. Right now, we use the same interface. So how the layers get loaded and initialized and all that stuff is the same between Android and Windows and Linux, but the loader itself is not. It was written from scratch. You know, Google has challenges sometimes with public domain software that says it's open and free, and then it suddenly becomes not to. Anyway, one of the interesting things that we lost was the JSON file. So the functionality is still there. You just have to call the layer to enumerate them from within the layer. And where's it supported? So all NuGet devices will have the Vulkan loader as part of the OS. So any Vulkan applications running on Android can run and at least query if there is Vulkan support on the system. Similarly, for developers, you look for the Vulkan header and libraries and all that stuff in the Android 24 API version. Did I just go? Nope. Sorry. Okay, layers. We talked about JSON. It is the same Windows and same source as Windows and Linux. There's a few ifdefs to handle the OS differences, but for the most part, it's exactly the same. And both LunarG and Google are running the layers and developing and extending the layers constantly. The Android environment does not allow things like implicit layers, right? Applications can't have somebody that just runs as part of their process. It doesn't work for Android. Another slight difference in Android, the validation layers, or any layers for that matter, are application resources, not system resources. So an application, you know, if you want to use it, that's fine, but you have to load it into your APK to be able to use that. Likewise, thank you. Likewise, some of the things about how you enable validation layers, like the Windows has a nice little shortcut. Since the list of layers can be platform dependent, or not platform, application dependent, the application has to spell them out, and we don't get to use that nice little shortcut. And
all right, I'm Tobin Ellis, and I work on the validation layers. So just a really quick overview here. If you have questions about specific layers, what they do, certainly bring those up. But basically the way the layers work is they sit in between the application and the graphics driver when you're developing, and they'll tell you what you're doing wrong in terms of how you're using the Vulkan API. So they'll flag errors, you register callbacks, they'll flag errors and warnings, and then when you're done developing, you want to get your app so that it's validation clean, and when you're done developing, you release the app without the layers, and therefore you don't suffer the performance penalty of all the checks that the layers run. So this is the list of the layers. The key one here is, I'd like to highlight, is just the core validation. He's kind of the heaviest weight layer. He stores a lot of state and does a lot of the more detailed checks involving all your pipeline state, your dynamic state. He does shader checking, and then memory tracking. So he's one that not only will catch a lot of kind of tricky errors, but he might also have some bugs in him. So when you're enabling the layers, as Courtney said, in Android, you have to explicitly enable each individual layer. And so I highlighted here that the threading layer actually has to be the first layer from the perspective of the application. It should be the top level layer just because of the way it handles the threading rules of the API. And then unique objects needs to be the last. And he does some remapping. So when you run with the layers, you'll see that all the handles for non-dispatchable objects will start off at 1 and they'll just start incrementing. And that's because of the unique objects layer. He'll remap all the handles to make sure that they're unique. And then at the top level there, you want to have parameter and object tracker should be earlier in the stack because they'll protect you from some errors that will occur later on in terms of having an invalid object. If you don't have object tracker there, you'll get invalid object, potentially crashing core validation layer or something like that. So that's the recommended kind of ordering for Android. And then you don't have to worry about any of that on desktop because there's the little shortcut of the standard validation layer. So that's what they look like today. And we realize that's not super friendly. So then we want to look into the distant future. So how far is the distant future? Just anywhere from a few months to hopefully less than a year. But what we'd like to do is move to a single core validation layer, and he's responsible for all of the top-level API intercepts. And then from that core validation layer, he can dispatch the checks to separate modules. Okay, and this will be more friendly from a development standpoint because right now core validation is over 10,000 lines of code. This will make core validation very thin, and then it will kind of isolate the related code into these functional modules. So we actually do have kind of the start of this is done in descriptor sets. I wrote just a separate module for that, and that works pretty well. And so we're trying to slowly move some of these other modules there. And that's just more of a theoretical list at this point, but just to show you how the modules could be divided out. And one advantage of this is that you can have what we call levels, and this is still just in the design phases. It's not a part of the API yet, but we'd like to have these levels that would enable you to explicitly turn on and off different sections of layers. And this would be an advantage because the layers have a performance penalty. And if you know that a section of your application is clean on how it's using descriptor sets, for example, you could just turn off those checks and you'd be avoiding that performance penalty. And so as you clean up different sections of your application, you could turn off certain checks and then not be suffering those performance penalties. All right, so that's kind of the details, and certainly any specific questions you have, bring them up.
Hi, my name is Mark Lobazinski, and I'm a layer wrangler for LunarG. I'm going to talk about 2 or 3 things here about using the validation layers, callbacks, settings file, and some execution control. There's 3 kinds of callbacks that you can use to get output from the validation layers. The temp callbacks are only used before and during the creation of the instance, so they're not of all that much use to once you've gotten that far, they don't help you a lot, but for some things they can be critical. Then there's, if you don't have an application-defined callback and you don't have a layer settings file, which I'll talk about in a minute, the layers will actually install some debug callbacks so that if you don't do anything and you have validation layers running, errors will still be logged as standard out and output debug string. And then the best thing to do, of course, is define your own callback in your application. And that gives you a lot more control about filtering and execution control. Layer settings file, this is a text config file which is described in the SDK and in the GitHub repo. But you can use this file to control which kind of messages are output on kind of a course level. And also to define where your output goes. You can log it to a file, and there's other options, especially for API dump layer. There's some additional options as well. And then about execution control, if you have an app-defined callback, you can actually return true or false, and that will either continue with the API call or just return and not make the API call at all. Either way, it's hard to say what's going to happen further down the line, but sometimes it's useful. I Then for usage and best practices, like Tobin said, standard validation is a good idea just because you don't have to worry about layer order. It's simpler. And also, as we move forward with the new design, layers will slowly disappear or get renamed. So this is a way to insulate yourself from those kind of changes. You should fix errors immediately because, like I said, once you get a validation error, execution from that point is undefined, and you could crash your driver or the other layers. So it's important to get errors fixed as you encounter them. Important thing we'd like to stress is that if you get a validation warning, that doesn't mean you did anything wrong. We get people saying, oh, this is a warning, but the spec says it's okay. That's more to make sure that users realize that they're doing something that they might not mean to do, but it's not a bad thing. And you can filter those out in your debug or turn off warnings entirely if you want to. Let's see, API dump layer right now is very useful for tracking down. We get a lot of questions about image layout transitions and stuff like that. You can use API dump to check through and make sure that you made those transitions as you expected. And that's the first thing we do, and someone says sends us an app with one of these problems is to get that and follow it backwards. It's a very useful tool, and I think it's probably underused. And then the last thing is if you're having trouble getting your layers set up or you're not sure they're there, you can set this environment variable. And that will print out a bunch of information, let you know if they're really there or not.
Okay, I'm Carl Schultz, also from LunarG, and let's go on here. Okay, as both Mark and Tobin explained, the validation layers are under very active development. You know, Tobin's talking about completely reorganizing the insides, and we're continually adding checks and additional functionality as time goes by. And as you can see, there's been a lot of issues recorded on the GitHub, and that can be kind of scary. But the good news is that there's also been a lot of commits to fix these issues. So all these fixes have been applied to GitHub, so you can get them in from the public repo. But they've also been delivered in about 8 SDKs since the Vulkan public release about 6 months ago. So the key takeaway here is that you really need to get the latest and greatest validation layers. We're fixing things daily, and a lot of times people submit issues, and we say, oh, we fixed this yesterday, so please update your layers as frequently as possible. Coverage is a bit tricky to quantify, but we feel like we have pretty good coverage over all the areas of the specification. We do need to go a little bit deeper in some places, and you can kind of see where those areas are right now. And that, again, that's ongoing work to dig in and get into the deeper, less traveled areas of Vulkan. So how can you guys help? Well, please submit issues. Please submit issues on the GitHub. It's the best place for us to process them. Ideally, see if you can get your problem described with a test case, some code that we can execute and test against. And if you're really, really crazy, you could dig into the validation layer source code and see if you can fix the problem, and then submit the fix as a patch, as a pull request to GitHub. That would be really great for us, but we'll take any kind of report. Also, false positives are an interesting area. So if you see something like a warning come up or an error in validation and you say, oh, I think I'm doing this right, but the validation layer is wrong, let us know about that too. And then finally, if there are specific SDK issues, another place to talk about those is the Lunar Exchange website. So I guess Rolando is next.
I'm going to interrupt for a moment. Carl, go back one slide. One thing I also wanted to add is that, yes, GitHub is the best place to put in your issues for validation layers and loaders, loader issues. Lunar Exchange, however, I know there have been situations where someone has an issue and for whatever reason they don't want it to be public, and everything on GitHub will be public. If you don't want your issue to be known publicly, Lunar Exchange does have a feature capability to submit it to us privately in what we call organizations, so that is another option there. But the real reason why I'm interrupting is because during my initial introduction, I intentionally left out a key point. So to now, you have been talking to the architects and developers of the loader and the validation layers. But what we thought would really be useful to bring here is someone who's actually used them as a developer. So Orlando's here from Epic Games, and he's going to talk to us a little bit about his experience as he was porting the Unreal Engine to Vulkan. And it's more real, I think, when you talk to someone who's actually used them that way, as opposed to the people who developed them. So now I'll be quiet.
Hey guys, I'm Rolando. I'm going to talk about how we're using the validation layers in Vulkan for the port. So basically, I'm going to talk about some issues we found. We start simple and then go to the more complex issues we found, and some nice picks in there. But tomorrow I'm going to have a more in-depth talk on the other birds of a feather for Vulkan, explaining how the code works for Vulkan on Unreal. So be sure to take a look tomorrow at that one. So basically, use the validation layers. You have to use them. The spec is complex, and the validation layers will guide you through some things you don't understand in the spec. Why use them? Well, you can find bugs. You can find cross-platform issues which are not apparent from the spec, and to check for performance issues. This is very vital to get the ProStar demo up and running, the one that in here. So start slow. With a simple case, you try to render with a sampler that got deleted, and this is the kind of message you get shown. Basically, invalid sampler object, and it'll give you the handle to the object. If you have the API dump enabled, or you have the pointer, you can or the handle of the object, you can see which one you deleted, and then try to render with. Just go a little bit harder. So we have this message: Q% cannot read invalid swap chain image 42A. Please fill the memory. So we run into this one. We are like, well, we're rendering to the back buffer. Why are we getting this? Turns out we had a frame where we didn't do begin end render pass, or we didn't do anything with the swap chain image. We just got the back buffer, did something with it, presented it, and then we used the next back buffer, but that one we didn't do anything for that frame. So this helped us find out that bug. This one is important because it's potentially a security issue where you get the back buffer from somewhere else. Could have web page information, depends on the driver if it didn't clear it. This is a case where we use bad image layouts. We just saw some nice corruption in there. And this is another case where we found missing barriers. So why do these kind of issues happen? On some hardware, on some GPUs, you have the memory for the texture, but there's also potentially additional metadata that could hold information for compression of the color data. So if you just regularly on D3D11, for example, you just call set render target, and then later on use the render target as a texture. So the driver will insert anything that it needs to do to control both memories. On Vulkan, you set the render target, and then you use it later. But the driver doesn't know that you want to do anything. It won't keep track of that extra set of memory. And that is handled by the layout and the barriers. So when you switch the image from color attachment to general or something else, or shader readable, then it will insert that flush of that extra memory. This is just another image showing those nice compression artifacts. So it's also very useful to find memory leaks. When you delete the device, you'll get a bunch of errors if you haven't deleted. In this case, for example, the messages are a little verbose, but you get used to them. In this case, it's showing basically that you see the italic part is shader module object 43D has not been destroyed. So basically a memory leak. Now we go to the nicer ones. So I like this one because it's very verbose. You read it a few times until you get the hang of it. The spoiler, the bold part is the important part. It's the actual error, but it's nice to see the full thing. So basically, when we call update descriptor sets, it failed to update binding number 1 because it's a combined image sampler that is using an image view that is set as a general layout. The format of this is set as the view is D24S8, so it's depth and stencil. So that's fine, But when you render to it, it's fine. It can have stencil and depth because that's what the format is. But if you try to read from it, you can only have depth or stencil. So you just go a few times over the messages, and if that's still not clear enough, then you can actually just see the call stack. And in this case, it's the same message basically. This is the call stack of the validation. Obviously, this changes with each SDK potentially. But the top of the call stack is our callback function. So that's where we printed out that message. So we added a assert or a break there. And then the line that's highlighted, the validate update descriptor sets, that's basically the source code where you would look and see why this message came up. So layers are great, but they have some significant costs, as it was mentioned. So you want to start with all the validation enabled with the standard validation, and then at some point when you're running very clean, you want to just at least keep the parameter validation layer. And then to detect memory leaks, you want to do the object tracker validation layer. This is in flux, as got mentioned, so this might change or not. So, but what is the actual cost of this? So I don't know if you can tell from this image, but it has some little stats. This is basically a sample template project you can run on Unreal. So this is with the validations on, and I'll get into more detail after that. And this is with the validations off. So you can see those little red lines in the middle is how much of the frame is it taking, and then after the validations are off, it goes to nothing. This is an Intel x64 optimized build. It has around 80 draw calls, and the total draw call time goes from 3 milliseconds to 0.26. Inside that time inside update descriptor sets went from 0.8 to 0.02 milliseconds, and the binding pipelines and descriptor sets went from 1 millisecond to 0.05. So it is quite a cost. So just keep that in mind when you're profiling. So I mentioned you can go step in the source code, and yes, you can read the spec, but it still might not be clear, even though we tried to make it clear. We still need a programmer's guide. We might be working on that at some point. But you have to read the source code to find why it's failing. However, the SDK is always improving. The last 4 versions, every time there's way more and more performance errors or new validation cases that are found, which is great. But there's always software inevitably has bugs. So just make sure that a new warning is not a false positive or it's a bug in the validation layers itself. Vulkan is great, it's very but it's very complex. So you have to use the layers. I can't stress that enough. And then finally, you probably want to have a second machine because sometimes it is a driver issue. You might get the blue screen of happiness, and then. So finally, write your own layers. You could write your own layers. You could take a look at GitHub, how to do that. You find any bugs, report them, and contribute. It's great. It's a community effort, so we should all be involved. Thanks.
Thank you, Rolando. So that's all the material we're going to show, because our real intent is that we wanted to be able to open it up for questions, exchange of information, dialogue. So now it's your turn, audience. If you have any questions, raise your hand or come forward. I'll give you the mic. I'd like you to ask it in the mic so that it can be heard by all. If you don't have some questions, I have some seed questions that I will ask. But yes, here, let me get the mic to you.
Hi. I'm a little bit worried about validation layer changing the behavior of my multi-threaded application while trying to report or catch or measure my mistakes in the Vulkan API. How worried should I be? Because I don't know whether validation layer holds a lock on to do some stuff or anything like that.
I would say not too worried. It's been run on some pretty complex applications, and generally it'll catch an error and tell you that there's an error, and then after that, the behavior could be modified, but you'll know about the error first. One key point that I don't think was brought up is you'll register your callback to get the errors, and the way that the callbacks work is that if you return true from your callback, that's telling the validation layers to basically skip that call down the chain. So if you're doing that, if you're returning true, that will definitely modify the behavior of your app because you won't get the call to the driver for whatever API triggered that error. If you return false, it'll still make the call, and if it's an error, it's generally going to result in some undefined behavior. But yeah, Rolando's running on pretty complex workloads, and we've run it on a fair amount of at least game workloads that are pretty complex and multi-threaded, and we don't see too many cases of the app modified behavior, and when we do, we fix those bugs. Thank you.
Okay, any more questions?
Hi there. I was wondering if you've run into, I don't know the right phrasing for this, but issues with the loader where there's security issues because you're essentially loading maybe an external DLL or something into a program. You might trigger some DRM, something like that.
I can address this so for Windows and Linux, I can address that question. So one is the loader will, that's one of the security reasons to have the JSON manifest files. So all of the initial queries like layer extensions, what layer properties and stuff are all encoded in the manifest file. So until the application actually enables the layer at create instance, none of the layer libraries are opened or brought into the process. It's just scanning the JSON files. And also then for implicit layers, there is an environment variable disable. So if there's an implicit layer that the application didn't want, you can disable that.
So what about layers they don't know about? For example, convoluted example, maybe like a game is loading up some hack layer or something that someone has developed where they can like see through walls or something they're doing with some weird interception.
So the app is explicitly enabling the layer?
An implicit one.
Oh, an implicit one, yeah. So we're thinking about adding an environment variable to disable all implicit layers, but the app, if the app knew about some implicit layer that it doesn't want to run with, it could disable those also. And also those implicit layers, yeah, so that's probably the biggest thing.
Okay, great, thank you.
Hi, so you talked about API dump. Like, is it the same format as the trace? Like, can you replay it?
No, it's not. We've been talking about that a lot, and we have, excuse me, Carl was just saying earlier that he has some ideas for ways that we could process that data and output it, but yeah, it's not the same thing right now.
Right, yeah, API dump's just a text output of the API calls, and right now it's really meant just for humans to look at, so you can see, what the API calls the application made. So it's really useful if you don't have the source, or even if you do have the source, you might have some questions, what is my app doing? There's, probably one of the things we might be looking at, and it won't take too much work, is we could have it generate essentially C code, so you could compile it and play with it again. I think the NVIDIA guys are adding that to their toolkit, and then that's in contrast with VK Trace, which is a tool that we use to record application data in binary in a kind of compressed text binary file, which tend to be very big, and then you can play them back later. So those are two completely different tools. And we can put in a plug to come to the Kronos BOFs tomorrow. We'll be spending a lot of time on those topics.
Thanks.
Hi, thanks for responding pretty quickly to the pull requests that I put up. I've just run into mostly like little compiler warnings and stuff when I build my own integration of the layers, and I was wondering if there's any like continuous integration or bots kind of stuff where if I make changes that, they'd show up like on your side so that I get the same set of warnings. It's a pretty subtle, small question, but.
Yeah. Okay, I'll start, I guess. Yeah, we try to keep our compilations as error and, well, obviously, and warning-free as possible. Sometimes you'll see some slight differences between, for example, Visual Studio 2013 compilers and Visual Studio 15 compilers, and a lot of times, tool chains will pop up that we haven't built on before, and we'll get reports of errors. But yeah, in general, we try to keep them clean, and I didn't read, I guess I missed part of your question, but.
Is there like
breaking anything in the validation layers. Ideally, the people who develop the extensions can go in and modify the validation layers. We realize that for certain extensions that can be a big task, so we're certainly willing to help with that as well. If you file GitHub issues and say, hey, I've got this extension and I'd like it to run with validation layers, we can help, if not implement it for you. So yeah, we'll see how it develops as there's more and more extensions. Right now, there's only a few extensions, and like the good example to start off is the WSI extension. And he's all handled. There's actually a separate validation layer that's called the swap chain layer that does all the validation related to that extension, make sure you're using it correctly, and all the other layers are modified to know about those handles and know how to pass things between the swap chain layer and themselves.
Oh, great, thank you.
Anybody else?
Hi. Only yesterday we heard about this initiative of wrapping Vulkan with C++, the VK CPP. Do you have any comment on that, or it's just transparent for you because it translates from C++ to Vulkan commands and then it calls onto your layers?
Yeah, it's transparent to the loader, right? So we don't really care.
And same with the layers. The layers actually have some utilities that do similar things already. It's not as comprehensive as I think the VKCPP effort, but there's a lot of utilities that are creating kind of wrapped versions of Vulkan objects and things like that.
Thank you.
Okay, I'm actually going to ask a question.
I want to ask a quick question. Do we have any Android developers in here? Oh man, that is not good. Okay.
Well, you know, that was really a timely question, because what I was going to ask is, how would I get a layer added to Android? But it doesn't seem like we have any Android developers in here, so perhaps it's not as interesting. But answer it anyhow. How would we get a layer added to Android?
Okay, so how would we get a layer added to Android? As I mentioned on the slides, the layers are an application resource on Android. They're not a system-level resource like they are for Windows and Linux. So to include a layer, and it could be any layer, right? It could be validation layers. It could be these other layers. An application includes it in their APK, and then during create instance references it as one of the layers that you want to load. Okay.
And another question, why isn't the loader owned by the OS like it is in OpenGL?
So it is a key component and so it's essential that it works, you know, consistently across platforms. And so it's very good that there's one source code for both Linux and Windows, and the interface on Android, Linux, and Windows is the same between the loader and the layers. And you know, frankly, it's not a Microsoft API, and so you know, that platform on Windows is they're not supporting a common thing. And you know, if you look at the experience with GL, you know, the equivalent GL loader is quite out of date, and so actually it's a good thing that Kronos has stepped up and, you know, is sponsoring it for Windows. And then the various Linux distributions are all packaging, you know, the loader from the GitHub repository.
Did I see a question? Someone raised their hand earlier. Yeah.
Hi, could you, just regarding, while we're talking about Android, can you reiterate why there was a distinction and why there was a need for a separate sort of scheme for handling loaders in Android? And then the other question following that is, I think you mentioned that, Courtney, you mentioned that the loader was actually built into the OS as opposed to being a dev time environment. Can you elaborate on the rationale behind that?
Okay. So why was it different? So one of the main reasons that the loader for Android is different is because we need to use internal APIs to deal with the Windows system interface, right? And these are, being internal APIs, we can change them over time as we need to, you know, to advance the platform. If we went with the same source code as the Windows and Linux, that would force us to use public APIs, which, you know, just don't provide the flexibility that we need. So that was a primary reason why that we had to do our own implementation. And then your second question was?
The fact that it's integrated into the OS as opposed to being a dev time, and
right.
The rationale behind that. And then I think there's actually an earlier question about that then impacts the flexibility of using, say, third-party layers and things like that. So it's just curious about how that's handled.
Right. So being part of the OS, the loader means that we can guarantee it's available to any application that wants to use Vulkan. We also can guarantee that it's the same version, that everyone's going to get the same version when you're on NuGet or whatever. The security models, well, the security is probably okay. The loader will only load resources that come from the application. And let's see, is there any other aspects of? I think that's the primary is that we want one loader to be responsible for everything. In Android, I don't know, nobody raised their hand for Android developers, but how an application gets run is very different from what the desktop is. And by providing a resource like the loader as part of the OS, it can already be loaded, right? So it's already part of any application image. You don't have to dynamically link it or anything like that. It's just there, and that helps with performance for Android applications. Did that answer your question? Maybe?
Yeah, I mean, so is there a mechanism at all for doing a third-party loader at all?
No.
No, or layer, not loader, but a third-party layer.
Oh, third-party layer. So layers are application resources. So an application can include whatever it wants layer-wise.
Oh, okay.
So that leads into a question I just wanted to ask everybody, if there's people out there developing layers, if anybody wants to talk about any experiences they've had if they are doing that. So I didn't know if anybody else was doing that.
I enjoyed it. That's previous stuff I did was with detours. So using the layer system was great. Actually ran into issues where I was trying to detour the layer system, and that did not work. But then I just bit the bullet and actually started using the layer system as intended, and it worked great. Didn't run into any issues. I didn't know about all the debug spew. That would be handy. I've always been running one of the, I think it's just one of the SDK examples, kind of has some debug spew built into it. But yeah, so just thank you, because it's been working great for me.
I want to highlight too, Rolando had a slide that I hadn't seen previously, but I thought it was interesting just for really quick technical details of the layer. You can see the layer stack through his call stack that he showed here. So when you look at it, if you can see it, yeah, so right here, you'll see it calling down, and then he hits at the top level the parameter validation layer. You can see right about the middle. And then parameter validation is calling into the device limits layer, which device limits actually went away now. It's part of core validation. And then he calls into the object tracker. And you can see each of these has their own intercept point. And so then object tracker gets to core validation, which is the one that is calling off into the descriptor set module I had talked about. And he's the one who's finally flagging the error. But that's just a good visual representation of how does that layer stack actually work. And each layer has its own intercepts, and they just get passed down. So what we'd like to see with the kind of updates to the architecture I mentioned is that you'll only see one top-level intercept going into core validation or standard validation, whatever we call it, and then you'll see separate calls for whatever module you're hitting for a particular error.
Quick related question to this, is it going to be policy to keep this synchronous so that the call stacks always do look good? I know with the KHR debug and OpenGL, there's asynchronous options, and you get a call stack that is not really valid.
Yeah, right now, there's a top-level layer. He's running without the threading layer, I just noticed. But threading layer has the biggest performance impact right now, and he locks everything, so he'll keep it synchronous. And he needs to lock to ensure that he's correctly tracking the threading behavior and use of the app. So yeah, right now, all plans are to keep it synchronous.
Could you go over the move to the new internal architecture. You were talking about splitting up the core validation into a number of modules, and how does that then relate to something like this, where you can, you've got a layer to layer to layer, and now we're going to somehow branch into a module to module to module kind of structure? Is that?
I don't think I put a backup. Did I put a backup slide about that? No. Okay. Yeah, I had a separate slide, but I didn't put it in here. Sorry about that. But the basic idea, and you published your document? Is that available? No, it's still not. Okay. We might publish a document that'll kind of go over the details of it, but the general idea is that almost all validation should occur before the call down the stack. That's not currently true in how we've implemented everything. We're trying to move things to there, but the idea is that you'll call into a top-level function like update descriptor sets. He'll call off into kind of the pre-call validation function. And then any modules that care about descriptor sets will then be called from the pre-call function. So all validation will kind of be in these pre-validate calls before you go down the chain. Once he ensures that the call is clean from a validation standpoint, it'll then call down the chain, and then you'll have, as necessary, there'll be a post-call that then it gets marshaled off to any modules that need their state updated based on the fact that the call completed. So that's kind of just the high-level image of it, and you'll see that if you look through the core validation code right now, you'll see the beginnings of that in most of the descriptor set related calls. There'll be these pre-validate calls, and they'll call into this descriptor set module. And so then each module that kind of cares about whatever API call you're calling, he'll have his own corollary to that API call. And so if there's 4 different modules that care about, begin render pass, you'll have this pre-begin render pass validate, and he'll call off into descriptor set and call off into memory and call off into the render pass module, and they'll each do whatever they need to validate that the state is correct in their module, and then pass back the pass or fail.
And why was that done as a separate construct, the modules, as opposed to just having breaking it into multiple layers, like having a descriptor set layer or descriptor set validation layer, and all of those things that you're talking about are now modules?
Yeah, I think the key benefit there is changing the layers can break applications. So for Android, especially right now, the applications will hard code the set of layers. And we'd like to not have to do that. So we'd like to just have one top-level intercept that will basically live for all time. And you won't have to worry about layers changing beneath you, and then you have to change your application because of that.
And the one of the problems that all this is trying to address is the layer ordering and dependencies. Like Tobin was saying, you need all those checks before you call down the chain. Well, each layer that was in the stack there is going to do its checks and call down the chain. So then we used to get reports all the time. People would call and say, I'm getting this core validation error, blah, 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 or the layer crashed, and it was because they didn't have the parameter validation layer before core validation. So another big advantage of this is that it gets rid of the layer dependencies entirely, because order does matter. You can leave out layers, like Rolando was saying, as you get further along, or if you just want to focus on one error or something like that. But you can also get yourself into trouble, and this will fix all of those problems, plus make it faster.
And part of the motivation there is that when we initially created the layers the way they were, it was done for a number of reasons, right? It was to be able to add or take away the list of layers that you wanted to use to control what's being tested. It also allows us to assign out those tasks to different people. But what we found is, as the layers developed, they copied each other's code, right? Many of the layers would be following the same state, because for the more sophisticated parts of the validation, it needs to keep track of it. And so it didn't make sense to have those guys be independent and copying everything. So we wanted to pull those together to optimize that performance.
More questions? Trying to get back to the first slide.
And then the other thing I can highlight from, we looked at Rolando's call stack, and he had taken out the threading layer. That's actually one little trick that you can do is First of all, if you're single-threaded, you don't need that layer, but there's since been an optimization there where it should be very thin now. It'll detect if you're single-threaded or not. But if you're multi-threaded and you're running with that and you know that you don't have threading issues, it hasn't flagged any issues, you can turn off that top-level threading layer just as a kind of a performance tweak. Do you know, Rolando, if your stats were taken with or without the threading layer? I'm curious now. Okay.
We have time for one more question, perhaps?
Is there any attempt from any of the layers to determine if there's a bug in the driver? Or is it mainly just aimed at, I don't know, just assuming that the driver is handling the call correctly?
So far, we have to assume that the driver is operating correctly, so.
Yeah, one thing we'd certainly be open to in the layers is that if you encounter driver bugs, if there's anything that a layer could do to kind of help to either warn or flag an error that would help with identifying those, probably it's going to be a warning for driver bug cases, but we can certainly add those types of checks in.
Okay.
Is there anything else you guys can think of that would be helpful to add? You know, that would make it easier for you guys to use the tools? Nope, okay, thought I'd ask.
Yeah, one last comment there. Jens pointed out the CTS Conformance Test Suite, which that's used to validate the drivers, and we want to emphasize here, please use the validation layers to validate your applications. So that's how the two things fit together.
Think of them as the conformance for applications, like CTS is conformance for hardware drivers.